Hello. In this video, we are going to learn how to calculate the inverse of a 2 by 2 matrix. So first, we have a matrix. Say the matrix is named A. It has 4 elements, A, B, C, and D. The first thing we need to calculate is the determinant. Because we are going to find the inverse, the first step is to say 1 over the determinant of A. A to the power of a negative 1 indicates A inverse. So that is stating that this is the inverse of matrix A. So it's 1 over whatever the determinant of A is times, okay, now we have to manipulate the matrix a little bit. The first diagonal, A and D, they are going to swap places. So now D is in the first spot and A is in the last spot. B and C are going to stay in their same spots. However, they are now going to be negative. You will take the scalar 1 over whatever your determinant is, distribute it to the matrix, and then you will have your inverse. Your answer will be a matrix. So let's look at an example. I gave you the matrix A equals 2, -1, 3, and 2. This is the same matrix from our previous video where we calculated the determinant, as seen on the left-hand side of your screen. So to find our inverse, first let's make sure we're using correct notation. So A inverse equals 1 over the determinant. And the determinant is 7 times, we need to swap A and D. So that's 2 and 2. They're the same number, so it didn't affect anything. Then we're going to bring down -1 and 3, except we're going to change their sign. So -1 is now positive, and 3 is now negative. Our next step is to distribute our 1 over 7 to everything in the matrix. So A inverse is going to equal 2 over 7, 1 over 7, -3 over 7, and 2 over 7. On the previous slide, I stated that your answer should always be a matrix, and that is what we have here, a matrix. So determinants, you're going to have a single number as your answer, but for inverses, you're going to have a matrix as your answer. Let's look at another example. This time I gave you the matrix 1, -1, -6, -3. We haven't seen this matrix before, so we are going to need to calculate the determinant. So the determinant of A is going to be 1 times -3, -1 times -6, and remember, subtraction always goes between our two directions. So we have -3 minus 6. So the determinant of A is -9. Now remember, A inverse is 1 over the determinant times D and A swap places, B and C change signs. So A inverse is 1 over our determinant, which is -9. A and D swap places, so -3 is in the top spot and 1 is in the last spot. And then B and C change signs. B and C, so -1 is now a +1 and -6 is now a +6. And we are going to distribute the scalar -1/9. So that's -3 over -9, -1 over -9, 6 over -9, and 1 over -9. So when we simplify all of this, I had to write it over here to the side because I was running out of room. -3 over -9 is 1/3. 1 over -9 is -1/9. 6 over -9 is -2/3. And then once again we have a -1/9. So that is our A inverse. Now, one thing I want you to think about is when would we not be able to have an inverse? What would make this undefined? Think about that, and in your assignment, you're going to have to figure out the answer to that, okay? So think about what would make the inverse undefined. What is a rule that we would break? What would happen? When you come up with an answer, shoot me a remind, and I'll let you know if it's correct or not. Okay, that's it for our inverse matrices.